All right. Good morning, good afternoon, and good evening, ladies and gentlemen. On behalf of WWF and the World Meteorological Organization, as well as the Global Atmosphere Watch Program, I am happy to welcome you to this webinar series for cities to a healthy urban life. My name is Tabaré Arroyo Currás, and I have the pleasure of serving you as a host in this first webinar. This is a webinar of a series of 3 webinars. This is the first one. And I'm also happy to introduce my co-host, Mario Peiro SP, official of the WMO. So today we will talk about clean air in cities. We will learn how air pollution is formed and what role meteorological processes play in further deterioration of air quality. Also, we will be introduced to tools that are used for reducing the impacts of air pollution in cities. I'm happy to present today's guest, Beatriz Cárdenas, Air Quality Director at the World Resource Institute, WRI, in Mexico, as well as Michel Gruter de la Mora, Research Scientist at the Center for Atmospheric Sciences at the National University Autonomous of Mexico. Welcome, Beatriz. Welcome, Michel. It's a pleasure to have you in this first webinar. So, without further delay, let's start chatting with our guests. And let's start. I am happy to invite to the stage to Michel Gruter. Michel, bienvenido. It's such an honor to have you here. Michel, you're a scientist, long time dedicated to atmospheric sciences. As I said, in fact, you work for the Center of the Atmospheric Sciences in Mexico National Autonomous University, one of the most important universities in the country. So I assume that if somebody knows about methods and atmospheric services available for cities, that one is you. So tell us your story, Michel. Why to talk about air quality? What tools are out there for cities to start assessing this topic?
Well, hello, everyone. It's very exciting for me to take part of this. In fact, this is very important issue to know what you need to take the correct decisions when you're talking about air quality. And I am happy to tell the story about Mexico City and about how the information, how the knowledge has been applied, has been used in order to transfer that knowledge into action, into policy. And for that, I'm really glad that the person who is also participating, Beatriz Cárdenas, is really an expert in the part of taking this knowledge and designing and implementing these policies because of her experience in both federal and local governments and also in these organizations. So my contribution, I would say, is rather the building of this information, as a scientist at UNAM. I would have to really tell you a secret. My education is not really in atmospheric sciences. I am a chemist, and I got really enthusiastic about the interaction between light, the electromagnetic radiation with matter. And I got specialized in remote sensing and spectroscopic techniques. And I thought I could put my expertise into doing a better assessment of what air pollution is looking like in cities like Mexico. And for that, I got interested in the field, and I've been working into determining the composition of the atmosphere for the last 22 years or so. And I got really excited about the topic in Mexico City because I always say to my colleagues, I have the largest laboratory in the world.
A very polluted one, huh?
Yes, so I thought of really 5 key points, key elements in building this infrastructure, to build this information And the first one is really the most important one, is to have a core observational network. I really believe that every taxpayer has the right to know what kind of air he's breathing, especially living in a large urban area with some degree of pollution. You are entitled to know what kind of air you're breathing, whether the air quality is good, bad, or regular, whatever. And for that, you need the institutions, the local governments to do something about it. And I have to say, Mexico has a long tradition of monitoring the air. Since the early 1990s, started to monitor the air pollution. And nowadays, Mexico has, very proud to say, one of the best monitoring networks in the world. It started really with only a few sites, a few stations measuring the air pollution, and now we have a very complete set, over 30 stations measuring continuously. So what are key points? It has to be a robust set of criteria pollutants that are measuring in each of these sites. Information has to be reliable. I mean, with that, I mean that the quality needs to be assured and controlled with proper calibrations of the instruments. And we need really continuous data and in real time, if possible, in every of these sites, if not in the most important ones. Here I show you two maps. Well, in the lower left, I should be able to point. Just give me a second. Maybe I can draw. Yes. So here you see the stations distributed along the metropolitan area. And here you have the information to the right, where these in different colors, whether I happened to choose here a day with bad pollution. Red means very bad, orange bad air quality, yellow is acceptable, and green is good air quality. And these are the type of instruments that are installed in these stations, and this is the in the lower right you see the kind of data that is being produced. You see in this time series the PM 2.5 information every minute or every hour. I don't know if this is almost 1 month of data. And there's a correlation between temperature, wind intensity, and the amount of particles detected in the air. And it was quite good in the introductory video that meteorology has a very important role in determining how good or bad the pollution episodes are. And I have to mention also that when I talk about core observational network, we are only talking about a very limited set of criteria pollutants. What do we mean about criteria pollutants? These are, I would say, like indicators. They only tell you how good or bad the air quality is, but they don't really give you much information about what the origin of these pollutants are, or where they're coming from, and so on. For that, we need a little bit more detail in the air quality. And for that, I go to point number 2, where in the next slide, I show you that it is important to have what we call the complementary or auxiliary measurements. In the case of Mexico, we have only a few sites where we have a larger number of instruments, what we call research grade super sites. These are on top of the criteria pollutants, we measure other parameters. For example, I was saying that the meteorology is very important, no? If you are in a confined place like Mexico City, where you have mountains all around it, sometimes the ventilation is not very efficient to blow all these contaminants away, and they accumulate over time. And there is when we have these episodes. So in 3 particular sites, in the south part of Mexico City, in the northern part of Mexico City, and also outside of Mexico City in a high altitude measuring site called Alzomoni, we have stations measuring all kinds of parameters which help us know what's going on also in the surroundings, because cities are many times affected also by other regions, no? From when we get transport of air pollution from wildfires, from agricultural fires, for example. It is usually the case in this time of the year. So we need to know how the wind is in that particular day, but also in different altitudes. For that, we need wind profilers. In the northern part of the city, here we see a device which tells us how intensive the wind is in different altitudes. Also, this instrument right here in the southern station, which is located in the UNAM campus, in the university campus, there we can also determine what the wind is looking like in different altitudes. This is very important. Another feature is to know what the composition of the aerosols are. And there we need instrumentation, which is not necessarily cheap, but tells you in the order of dozens or even hundreds of compounds within the suspended particles. And then we can build like this, we can gain knowledge about what the composition of these aerosols is, whether they are primary aerosols, that means they are emitted directly from the sources, or they are formed in the air through photochemical reactions, like in the case of the secondary aerosols. And for that, we need really sophisticated equipment, which we have in the UNAM site. And the other very useful set of instrumentation is the remote sensing instruments. In this plot right here, you see that in the progress of the day, the mixing layer height is increasing because of thermal heating of the lowest layer of the atmosphere, and this increase in the height increases also the volume in which these contaminants are contained, and then this has an effect in the surface concentration of all these pollutants. So we need to know all of this information. It is important to gather most of the parameters that we can and record this data. The third key element, which I thought is important in building this infrastructure, is to organize every once in a while a field campaign, because there the objective is to answer specific questions. You know? Whether the pollution is being transported, then you need to be capable of moving your instruments towards that location and getting evidence from what the models are reporting. No? Here, I go straight to the fourth point and last point, which is once all this information is gathered and you have evidence, then you can run the air quality models and know how reliable these air quality models are, because the air quality models are at the end the tool which will allow you to do a true assessment of what happens in case you implement one measure to mitigate the emission of this pollutant, or this other measure to decrease these other pollutants, and what will be the effect on the resulting surface concentrations. So I will just stop here and just let you think about this. I mean, it is ideal to work on these 4 key elements. Sometimes you can do 1 or 2, but I think it is important to move in parallel with all these these tools that we need in order to do a proper assessment of the air quality.
So we said in Mexico, the more the merrier, correct? So you mentioned you mentioned four particular approaches: the observational work, if I am not mistaken, auxiliary services, field campaign-based research, and modeling. So this is like the top four of the things that at minimum a city should have in order to assess properly the air quality in cities. So tell me, this is very interesting, but now I wanted to ask you, Michel, to conclude this first part of your presentation. I guess the instrumentation, atmospheric measurements there are always some best practices or good practices. So I was wondering if you could provide us some ideas of what recommendations you can give to the city officials in terms of monitoring, besides these four elements that you have already presented.
Well, very interesting that you mentioned that, because there are some good practices. We know what these good practices are. Sometimes it's really difficult to practice these things because of the complexity of the institutions, of the people involved. But the first point I would like to stress is, yeah, like in the slide, that we have open data. Now, this is, I mean, it is so important for the data to be openly and freely available for the people to use, no? Because this is how you will trigger all this research and favor the collaboration, which is the second point. So I truly believe that everything that we do in terms of data production, no? Whether it is the government agencies or the academia, we need to put all the data publicly available. This is not sometimes easy, because people usually think that if they have a grant to produce some data set, they are owners of this data, and it is really difficult to convince them that this grant came from public money and they really need to, I mean, this is the data doesn't belong to us scientists, it belongs to the public, you know. But we are moving towards that. No, it is. There's some constraints, but we are moving towards having all this data available. If not immediately, maybe after some time, all of this data should be. And also, some time needs to be dedicated in making this data user-friendly for all the community, because not only scientists are using this data, but the general public, just like I said before, to know what the air quality is, whether they go out for a run or not, because it's a particularly bad.
Very common in Mexico City, correct?
Yes. So there are two pictures on the right. This is what we really would like the skies to look like every day. No, I mean, not every day is a beautiful weather day, but we really would, this is what we aim for, not to have good air quality every day of the year. And for that are these good practices. I mentioned the collaboration among data provided, among academia is very important. And to have the practice of discussing the problem with among scientists and decision makers during pollution episodes, for example, that we take the correct actions, no? That we discuss the problem, the special situation. And for example, during this crisis that we're living in right now, where we have much lower mobility due to the pandemic, no? And people are staying at home, so the emissions are changing. People think that if you reduce the mobility 60–70%, then you will also reduce air quality, or you will improve air quality by 60–70%, and this is completely wrong, no? because people are still consuming energy, they are cooking, they are taking their baths, and domestic emissions become really important, and trash handling and residuals. These are also big emitters, and we are looking at the time series at the data, and we are having these discussions now through this type of not going to meetings, but through this type of
Not more
virtual
webinars.
meetings. Exactly, but this is a very important point. It's a good practice, I would say. And then start thinking about the format of the data which is being produced, that is homogeneous, that is compatible, so that different users can have good access to this data. That you can compare apples with apples, no? In the case that there are two different instruments measuring that same parameter. But if you want to compare or relate an apple with a pear, then you have the same units, for example, or same time format in which you acquire that parameter. Is also very important that the communities build their own guidelines how to produce these data sets and what the format should be. Redundancy is another important point, because it's good to have redundancy. For example, if within a city there are 2 or 3 groups running air quality models, this is a really good practice, because this is also what we do with climate models. No, we compare results, and then usually we take the average. No,
so you're saying this is not a crystal ball. We are doing.
No, models need to be constantly checked whether they are reliable or not. This is why we need the measurements to begin with, but also they need to be compared with each other, no? And this is about the redundancy is great as long as data and experiences are shared. And this can be through this type of forums that I was talking about earlier, or present data or results in workshops or whatever, no?
Perfect.
And the last, sorry?
No, go ahead.
The last point I wanted to make is really a dream that we all have. No, we're not there yet, but is to have a common repository where all this data goes, no, and to have this sort of geographical system or a map where you can just click and choose what parameter you want, and have access, user-friendly access to this data from every institution is really what we should be aiming for, because there's an acquired value of things when all data is put together and analyzed in conjunction, no? In order to make the best decisions what to do next in order to move towards getting a better air quality. And this is a task in which we scientists and the decisions maker are in together, and we need to work together in this direction.
Fascinating. Mitchell, you have no idea. At the moment, we have already several questions that we will follow up shortly. I think your presentation has caused lots of interest. And so for the audience, we will have answering your questions in a second stage of this webinar. But for the meantime, thank you very much, Mitchell. I think this has been very useful to introduce the topic. And now we have talked about the science, about the facts, about the data. Now, quite interesting is to hear the other side of the story, the one that relates more to the policy side. And from that perspective, I'm also very happy to invite to this virtual stage my other guest, Beatriz. Beatriz, bienvenida. It's great to have you. I think Mitchell has introduced you already. Well, what else? You have worked as a general director for air quality management for a long time. You participated in this field in the Mexico City Secretary of Environment government. But not only from the policy side, you also have several years of actual research associated to air pollution. So I guess you can also tell us a lot about air pollution in Mexico City. I myself, I must admit, I live in Mexico City for some times already. And when I was thinking about this webinar, I was thinking, well, has anything really changed over the last 10, 20 years, 30 years in Mexico City? I mean, Mexico City, to me, it resembles a very polluted city. Is that the case? Is that really the case?
Well, thank you so much. Thank you, everyone. And that's a good question. And I appreciated that you asked that question to the whole audience. Thank you so much for inviting me to this webinar. I'm really honored and happy to also share this webinar with Michel. Not only because he's a very well-known scientist, but also I guess we have shared some of this learning experience over the years, and that's very interesting. So I'm very glad. So I'm looking at the poll. And I have to say that that I do these questions sometimes in my talk. So if you can change we can go to the next. So that's a big question, and actually that's something that we as scientists and policymakers ask our own. And based on what Michelle says, yes, how can we know if the air quality has improved? We need data, and we need reliable data, and we need long-term data, and we need to have access to that data, not only few people, not only in scientific papers that are really good, but also we need that information and knowledge produced by policymakers or by the governments. And that's where the air quality monitoring comes in the stage. So this, I would like you to see these two mosaics, they call. These are being produced by Mexico City Environment Secretary, the air quality area. And you can see, I mean, it's really, what Michelle was saying is, how can you get a good communication with the citizens, with different stakeholders, private sector, and other people that are not working in air quality, to get them know that, yes, you may reduce emissions. As Michelle was saying, yes, you cannot use your car, you can reduce some activities, but you still have some pollution. So how can you explain that? One very important thing is just to consider that the air pollutants are emitted in one place, they react once they are in the atmosphere, and they can move. And you can either export or import pollutants. And the air pollution change over the day, and the different pollutants change over the day. Yes, we have some criteria pollutants, some indicators that can tell you how is the air quality that moment that you are looking at. But there are so many other species that we don't report. And as Michelle was saying, yes, thanks that there are other groups that are studying that big range of air pollutants, we can know that they are there and how they behave, and they could actually impact on the air quality. So look at the map, at the mosaic that is ozone 1 hour maximum. That means that every hour you know what is the air pollution or the air concentration, the concentration of any pollutant. So for ozone is a secondary pollutant. That means that it's not emitted by any source. So it's formed in the atmosphere once you have two precursors, nitrogen oxides and VOCs. And these are emitted mainly by NOxes, or nitrogen oxides are emitted every time that you have any combustion. You burn a fuel, either biomass or fossil fuel, and then you have that in the atmosphere and it starts reacting. The formation of ozone is a very complex reaction and actually involves many steps, but you also need radiation. You need the energy, and that comes from the sun. So if you see that, so that mosaic, see the first layer or the first row is 1990. And each little square represents the highest concentration measured in 1 hour of ozone of that day. So how can you know that the air quality has improved? Well, as Michelle mentioned, purple means really, really bad air quality, and green means okay, or regular or good. It depends what air quality index you are using. But if you go to the top, which is 1990, to the bottom, which is 2020, April. So if you see the row, the last row is April 2020, and they just put that in the web page. So you can see that if the air quality would not have been improved, you will still see like purple reds over the whole column. But now you see less and less purple. Actually, you don't see purple. I guess the last purple was 1 hour in 2016, 1 hour, when during the 1990, you will have not only one monitoring station with purple, you will have many monitoring stations, and not only 1 hour, you will have many hours, right? So how was that possible? Well, it required many activities, but you will never be able to not only show that that has changed, but also try to understand what happened. And that's possible because you have a lot of data. And that data, following what the good practices that Michelle was saying, it's actually public. You need that public data. And you need also to incorporate other data, other knowledge that has been produced not only by scientists, which is really, really important, but also by other organizations from the society that actually has been produced some data. So the right column that you have, the mosaic that you will see is PM 2.5. That's not such a long column, as you can see, because it started monitoring in 2004. So our regulations for Mexico, it require monitoring PM 2.5 only in 2003. It started, actually the standard was published in 2003. And little by little, some monitoring stations from different states were starting to measure PM 2.5. If you don't measure, you cannot know what is the problem, and you cannot track back if it's actually getting better. And the most important, you cannot tell the society, you cannot tell the people how is the pollution and how it's affecting, and how can they do, and what can they do in terms of at least preventing or reducing their exposure. So if we go to the next one. So I guess I would like to see the poll. How was that? So people believe or not?
So the poll is very close. It is still open. So if somebody wants to vote, I can tell you it's pretty tight at the moment. So there are about half of the participation. By the way, we are 120 people participating in this webinar. Thank you, all of you. So if you have still not voted, please feel free to do it now. So let's give a couple more minutes, Beatriz, and I tell you.
Good. So one of the things that you can see, I mean, how can you know if actually the data is there, and how can you know if the air quality has improved? It depends. I mean, air quality, talking about air quality is so broad, so you have to talk about, has the concentration of any specific pollutant has been improved, has increased, or what is the concentration? And then that's what you go into very specific pollutants. I was talking of ozone, I was talking of PM 2.5, but there are other criteria pollutants. And criteria pollutant means that since there's a standard, a regulation, the government needs to measure that, and they should inform people. There are many other pollutants that are there. They are not being measured, not continuously. And it depends on the countries or the cities if they want to have that pollutants as criteria. That requires, I mean, having a criteria pollutant means that you have to measure, and that requires a lot of effort, not only in funding, I mean, money. You need to buy the equipment, you need to operate the equipment accordingly to standards to assure quality and to assure the control of the data. But you also need people to not only operate the equipment, but also to do an analysis of the data. So the importance is not measuring and measuring. The important thing is knowledge, is what you get the data and what you do with the data, what you try to understand with the data. Because sometimes it seems like measuring and having an instrument operating, that's the whole thing. And now we have the opportunity to have low-cost sensors, which can increase the amount of data, But that it doesn't become a data until that number you actually explain, you assure that it's a good and representative data, and then you're trying to incorporate into the knowledge what that means. If I am getting an information from a sensor that is in the street, is that the same or different than if I put it in the top of a building? Well, that depends on what the objective of your monitoring. So here, what I'm showing in this slide is that because of Mexico City has more than 30 years of data, and they have actually been a huge effort to implement quality assurance and quality control. That's what, how can you not only produce the data, but actually present the data. So I invite you to take a look at the webpage of Mexico City, because you can download all the air quality reports. And that's very important, because after having so much data, you need to do an analysis of the data. And you need to see if what happened that year is actually representative, or that's actually linked with the meteorological condition. Now that's a key issue, and here I put my big point to the WMO. I guess what we need is a very strong organization, as WMO is, and we need a lot of collaboration, not only to the national governments, but also to the local governments, because meteorological information, observations are so important that we need to strengthen the capabilities of the cities and the national governments, but also link more and more with the scientists. So this is a good example that every year you can see well, every 1 or 2 years, they produce this report, and you can see the trends, and you can actually go into detail, because Mexico City, in addition to these criteria pollutants, has been also measuring acid and wet and dry deposition. And that's very important. That also tells you a lot about the impact, not only in human health, but in our biodiversity and our food production. So if we go to the next one, here the other very important part is the emissions inventory. So that's how we measure, how we know who emits what, when and where. So that's important, not only, yes, vehicles are emitting any tons of NOx, yes, at what time, what type of vehicles, what type of vehicles are actually the most emitters, the high emitters, and how that it's been seen, or actually in terms of exposure. Emissions inventory are very important part that has to be fed into the air quality models that Michelle was mentioning. If we want to know how the pollutants move and react in an area, we need to know who and where and what pollutants are emitted. And then we actually feed that information in a chemical model. We actually took the meteorological data, and then we have a very complex model that could tell you how is the pollution being produced. So here I'm showing also the emissions inventory in Mexico City is also quite an effort. They updated their emissions inventory every 2 years. Probably it's too frequent. Usually you recommend that 5 years or less, but that requires a lot of effort. But that can tell you how the emissions are changing and where are they emitted. So in the graph that you will see in your left side of the screen, you will see that if you ask yourself who is emitting NO2, which is the red part, then you will see in the left part what sources are actually the causes of the sources of emissions for NO2. And then you will see that mobile sources are the main, but then you have also fixed sources like industrial sources, and you can have also other type of emissions. So that will tell you not only who is emitting, and that will also give you some ideas of what programs you should have, you need to implement in order to reduce that emissions. Again, as Michelle mentioned, that doesn't mean that you will have to right away some pollutants being reduced because of all these reactions. In terms of NO2, it's actually a tricky point, because in atmospheres like Mexico City, if you reduce the emissions on NO2, you may have higher concentrations of ozone, because NO2 reacts with ozone at certain points. It's a precursor, but it's also it titrates the ozone. So that is not intuitive. And people sometimes don't believe that decision makers are not actually considered the science. And sometimes they are not, but in some cases that's true. And we need to be in more communication in order to get. The other very important thing that I guess as a case study of Mexico City is the scientific field campaign. And we all remember, at least many of who are still working, and in that time we were having many young PhD students, and now they are scientists, or as cases of Michelle, they were already the researchers and they were doing a lot of work in that time. It was a huge campaign, field campaign, that actually has so many questions. And one of them was, how a mega city, how can we take as a case study of mega city of Mexico City, when the pollutants are emitted, where do they go? And what is the impact to other areas? So that was a mega city mirage experiment. So it was actually 4 field campaigns altogether, but we also have our own questions in terms of Mexico City metropolitan area. And that was Milagro. And in that field campaign, it was amazing. There were many research groups coming not only from Mexico, from the US, from Europe. It was a lot of information, a lot of network created. And it was very important that the government in that time, both the local and the federal, were actually involved. So they were also part of those who were making the questions, and the scientists were actually doing trying to get the answers. And later, it was a lot of work to get what that means in terms of policy. So if we go to the next one, I will go faster. So, well, this is just, I have some examples of what that field campaign generates. So of course, there was a lot of work with kids, actually, to children and young people, to get some idea what the air quality was. So it's very interesting if you can go to the webpage of the MCE2. The list of all the papers that were produced in that time, 2 examples of those papers, and then all that information was actually used to design the ProAire, which is the air quality program. So we go to next one. There's also a lot of information and a lot of good collaboration between scientists from the health expertise, that if you have a lot of information, as I showed before, of air quality over the years and in different parts of the city, and you have epidemiological data, then you can make a match, and then you can know, like in this case, this study actually showed that reducing the air quality, improving the air quality, or reducing the concentration of pollutants, PM 2.5 and ozone, have very specific health impacts. So in Mexico, not only there were 22,000 premature deaths avoided because of that improvement in air quality, but also the life expectancy change. It was increased. And since you have that quality of data, and you can have not only epidemiologists, but also policymakers and atmospheric scientists, then you can get into this conclusion. The next one. And finally, what you need is, as Michelle mentioned, I totally agree with him, and we have to still fighting and make this connection, because I agree with him, not only scientists, but also a lot of policymakers, they don't want to share data, and the data is open, they should be open, and they should be easily available. And actually, you not only need the on-time data, the real-time data, you also need the validated data. And that's, we still have in Mexico in general, a lot of areas of opportunity. Fortunately, in Mexico City, they have doing a lot of good work. So here's just an example. And it goes into how you get that information, real-time data, into all the citizens. So you can have that in your app, in your phone, and you can, every hour, you can see what is the concentration of, what is the air quality in the areas you are. It can give you some ideas in terms of forecast. That's very important. If you don't know how the day is going to be, and you don't know what is the meteorological conditions going to impact the air quality, in addition to emissions, then you will not know at what time the worst concentration of pollutants will be. And there is an app. I actually invite you to see the health risk index, which is actually possible when you have epidemiological data plus air quality data, and the openness. You can go and download data from 1990 if you want. And that should be the case of all cities. all the information that is being produced needs to be open in order to be discussed.
Perfect. Thanks very much, Beatriz. Wow. Living such a long time in Mexico City and not knowing all of this, I feel complete silly. Very interesting. 22,000 life avoided, saved due to improvements in air quality, life expectancy of people increase. So those are great news, and that's a proof that in these contingency times, measuring the atmospheric conditions as well as the air quality is so fundamental. So we really need to rush because we are ending this webinar. We just have 60 minutes, and I still would like to have some questions from the public. We have many questions to you as well, Beatriz. I'm sharing the results of the poll. So as you can see at the moment, about 62% of the people, I think they do believe Mexico City has improved over the last 30 years. Thank you for all that participated. To end up your presentation, Beatriz, I have a question to you. This is so cool. What's the story behind this picture? Tell us.
Well, I am from Mexico City itself, and I am, I mean, since I started working in environmental area and then in air quality, I'm so fascinated in understanding what the sources and how the pollutant moves. But when we don't take into account that first, if we're working for government, we're working for the public good. When we are working as a scientist, we are also trying to get some information for something or to answer some questions. And as I'm working in an organization as I am, all becomes to people. I mean, to people as part of a whole planet. So when we want to get an idea what's going on in terms of air quality, we definitely have to be on the ground and get an idea of what all of the activities actually means in terms of pollutants. And we need to transmit that information. So this is a picture in Madero, actually in Eje Central. So that avenue is one of the largest one in Mexico City, and it's amazing. I mean, you can be in a Saturday and a Sunday crossing the street and you will see how the people actually it's moving, how many people there are. But it's a very nice story behind, and you will not see the street behind, which is Madero. And Madero was we used to be a street for cars, and it became pedestrian, and is now one of the most walkable street in Mexico. It actually has a lot of issues of revenues in those business that they are. But that's, and again, an example of how we as a citizens can shape not only our air quality for good and bad, but also we can make changes. So that would be all.
Thanks, Beatriz. 350,000 people walk every day over that street. Am I correct?
Yeah. Yeah.
So it's probably the most transit street in Mexico City. So 350,000 people. You can imagine how crazy it is. Well, Beatriz, that was lovely. Michelle, thank you very much. Let's move into a very quick, so we have 10 more minutes and we have lots of very nice questions from the public. So, wow, I don't know where to start. I see questions that have been submitted to us, and there have been also some questions in the chat. There was one that I wanted to read you because I thought it was very good one. And this, I would just read it this way. In order to properly evaluate air quality, one of the crucial parts is to produce the quality of data. Otherwise, all activities after collecting data will not be reliable. So the question is how to maintain the quality of data and how to assure that the methodological traceability of data. If you could just quickly answer, not to extend too much. Any of you, Beatriz or Mitchell?
Well, I will just very briefly, as knowing how is the condition from the government side, both those public officers and the society in general general, they actually have to consider that they need to devote some resources, human and economical resources, and those who use the data, they need to demand the data. Michelle?
I just wanted to add to that. It's a very interesting question because one has to always take into account that any data point taken by any instrument needs to be calibrated or assessed or evaluated, because as I tell my students all of the time, a number without unit is not a number, or you have to describe the number. What does it say? What is its uncertainty? Otherwise, it has no value. No, and there always needs to be some effort to put some uncertainty into these values, and for that we need calibrations, and we need to do intercomparisons, to do long time following of how the instruments are working, and so on.
Thank you. So let me tell you, I mean, it's amazing. There are a lot of questions. There's people from Nigeria, Malaysia, Latin America in this webinar. So thank you all for participating. There's one in here for you, Michelle, and then maybe you can also answer, Beatriz. And probably this could be, unfortunately, the last one that we could cover. It says, I would just read it, interested if Michelle could talk about if there have been any opportunities for citizen science strategies to contribute to the monitoring of air quality in Mexican cities. This is a very good question, a very wise one, because it is actually touching those elements that you mentioned, like collaborative science making, action research, all these buzzy words. So, Mitchell, what do you think about this one?
I completely agree that the citizens need to be involved in the data production, in the communication of what their impression is about air quality in their environment. There are several opportunities. Nowadays, you can buy these low-cost sensors in order to measure, of course, with limited quality, but it's already some good information about how the air quality is in a particular location. But I would go a little bit further. I mean, I mentioned in the beginning of my intervention that really what fascinates me, particularly in my research area in remote sensing, is that we can determine how light interacts with matter or with pollution, no? And in fact, everyone is doing everyone has remote sensors at home, or even they're wearing remote sensor, which is the eyes, no? And the first thing that most of the people do when they look out of the window is see, oh, how is the pollution today, or how is the weather, many clouds, or is... And there are ways how to communicate that in sort of chats or feed information systems on these. There are even some networks or how you can contribute with your perceptions, how the pollution is one day or the other, because there are some particular characteristics, whether the sky is blue or whether it's more whitish, whether it's hazy or you don't know if it's haze or it's smoke. These things tell you a lot of information, and remote sensors do the same thing, a little bit with more spectral analysis into this, but they do the same things. But with this, in one of my slides, I showed you that we are testing in the lab some low-cost sensors to detect or build a dense network of CO2 measuring devices, which are not very expensive, and they all can contribute to the knowledge we have about also spatial distribution and temporal variability of these gases, which also with techniques like big data analysis and machine learning, we can already learn a lot about what is going on. So there's a lot of opportunities about citizen science, and the more the people are involved and aware, I think the better we're off, because also this makes a very key element, which I didn't put in my slide, which is conscience.
Conscious, yes.
No, because as long as people are conscious about what their actions are contributing to air quality, then this is immediately already a benefit for society.
You remind me the lyrics of Peter Gabriel, lost my time, lost my place in the sky blue. What a lovely thing. So I think we really need to.
I would just like to mention that we do have a couple of experiences of, we are not calling citizen science, we're calling collective science, because we are involving the policymakers from the cities. And we did some exercise last year and the beginning of this year of in Guanajuato, in León, Guanajuato, and Guadalajara metropolitan area. So soon we hope to share with you some results. But I totally agree. This is the way, and we have to raise awareness of how we contribute for the good and for the bad to air pollution.
Perfect. Well, Beatriz, Michelle, thank you very much for this extraordinary conversation. I'm afraid we really need to start closing the webinar. In the end, we have 60 minutes. There are still many questions out there that we have not been able to answer. Please keep them, send them to us. We will do our best to respond to them. But more importantly, maybe some of them can be actually answered in our next webinar. Our next webinar is scheduled for May 6, 11 Central European Time. This one is about multi-hazard adaptation in cities, a webinar series for cities committed to a healthy urban life. In this case, well, I will be a spoiler, but we will talk about another big, really big city. So not tell you more. Please join us on May 6th for this next webinar. If you have your questions unanswered, please feel free to send it to us, to the World Meteorological Organization, or to WWF. Probably we will redirect the questions to WMO. In any case, thanks very much for joining this webinar. I hope it was of your interest, and hopefully we will see you in our next webinar. Michelle, dear Beatriz, and also dear Mario, on behalf of WWF and the World Meteorological Organization, thanks for participating in this webinar. So the webinar is ending now. You may all go in peace. Thank you very much.
Bye-bye.
Thank you very much.
Bye.